All right, so let's carry on where we left off. We'll talk a little bit more about identity. So if you've selected ADFS, if you want to federate with an on-premises Active Directory, or maybe just a portable Active Directory that's riding along beside your Azure Stack, there's just a few things to help you have that conversation with the customer. So all of the components of the fabric of Azure Stack talk to an internal Active Directory. I said there's some domain controllers in there. All the virtual machines are members of that Active Directory. So they're all participating in a hidden Active Directory that's riding inside Azure Stack. If you choose Active Directory with ADFS as your identity provider, an ADFS service will be configured on the inside of Azure Stack. And the Active Directory you pointed to in your configuration will be what we federate with outside of Azure Stack. So you'll see down there that it's called ADFS.AzureStack.local as an example here in my tenant. That ADFS will be automatically configured to federate with an Active Directory outside of the Azure Stack. So in a completely disconnected, isolated scenario, like what Robert was mentioning with the drilling platform, you might ride an Active Directory alongside Azure Stack, right? So you might have another server sat out beside which runs some auxiliary services outside of Azure Stack. One of those could be an Active Directory.
So I find that trying to draw analogies to things that people already know and relate them to this helps. Whether it be a server or workstation in the Windows world, domain joined, it goes to an Active Directory domain. Hopefully everybody's familiar with that. But what happens when I'm on my laptop at 30,000 feet? There's no Active Directory anywhere near me, but I can still log on with my domain information to that. How does that happen? There's a thing called a cache credentials in a thing called an LSA, Local Security Authority, that can store that information for me. Well, guess what? That doesn't exist here. There's no caching of information within the scale units. So it's not like you can take it offline and have some known accounts. The only accounts that exist there are the ones that exist in some repository, either Azure Active Directory or ADFS, to get those accounts. So it doesn't store anything locally. So it always has to be able to get to something to say, hey, do you know who this person is? Okay? So hopefully that analogy works for you. There is no cached credentials. It's not like, oh, I logged in 3 days ago and the internet's down and can I log in again, right? It's at some point in time, it can bounce you off to an account that you can get to maybe through some other method, but it doesn't have those cached credentials, okay?
Now, Azure Stack could quite happily start itself up without contacting this external, the green Active Directory. It'll start up because it's got enough internal structure to run all its VMs. So you can turn it on and it will start up with that Active Directory not being available. All the user workloads running in there can also start up. But if anyone needs to go to use the portal or connect to the ARM endpoint, that's not going to work without you providing your identity. So it is actually fully possible to have just an Azure Stack with no directory connected, turn it on, and a bunch of websites would pop up. And if you can access them anonymously, hey presto, you're golden. But yeah, for any kind of operation, any administration by either the operators or by the users, you would need that Active Directory to be available. So that's available. ADFS is available for either connected or disconnected scenarios. If you are disconnected, you must have an Active Directory accessible to your Azure Stack scale unit to be connected. The way that we connect to the directory is called the AD graph. So it's a web service. It's running inside Azure Stack, this AD graph. All of the identity calls will go through there, and they basically go out and they make an LDAP call to an external directory. So if you're on-premises Active Directory there. So just keep in mind that there's a special service that mediates all of those conversations between services within Azure Stack that need authentication and the external Active Directory. So you'll see the LDAP traffic is one of the types of traffics that you must allow to be emitted from Azure Stack to talk to your on-premises Active Directory. Also, obviously important is if you're going to talk to an Active Directory somewhere, DNS needs to be working properly. So we had a little picture of this before. There are a few things that you can configure on the DNS side that you need to be aware of. So in this picture, you have an internal Azure Stack DNS. It's running in the Active Directory environment. It will be configured to forward requests out to the DNS zone that's running in your infrastructure. So that uses a conditional forwarder. So that's how Azure Stack resources resolve names out on the data center or out to the internet. You also might want names, well, you probably will want names for services running inside Azure Stack, like user workloads, to be resolved by a workstation or a person sitting outside. So you have your choice of how to implement that. And they would be normal DNS choices. So for example, if we had, let's say it's application number 7.azurestackexternal.pat.com is the name of my service. I could configure DNS in my environment to do one of the normal DNS things to resolve that name that it can't understand. So that can be conditional forwarding. So you can say, hey, if you see pat.com come, I'm going to send the request over back to the Azure Stack DNS. You can do delegation, so you can say any names in pat.com are responsible by this server, etc. So this is just sort of a normal DNS design, but keep in mind that although the configuration for names being resolved coming out from Azure Stack is part of the default configuration, when you need to resolve names going back into Azure Stack, you're going to need to do something to your DNS to enable that. So it's just really pointing all the names that Azure Stack is responsible for to go back to the Azure Stack DNS. And you can also see that there's an important distinction here, which is there's a bunch of names that are only ever used inside Azure Stack. So the domain to which all those Fabric VMs are joined to, nobody ever needs to know those names outside. What the external users do need to know is names for any services that they're going to connect to. And a lot of that, the internal stuff is all automatically configured. So here's a few options I just talked about. So the most common ways are to configure conditional forwarding for the DNS to know what to send into Azure Stack. You could just have individual host records. So you could say app number 7, I'm just going to answer that question myself. I'm not going to bother referring to the Azure Stack DNS. Or you could do delegation, say, hey, any names in pat.com, I know they're all residing over there in Azure Stack. I'll just delegate that namespace over to the internal DNS server. So that's all normal DNS design stuff. But you can see, again, there's scope for you as advisors to your end customers to do this analysis and offer a solution or a design for them. So here's what's supported. Obviously, if you're going to talk from the ADFS and the Active Directory inside Azure Stack to ADFS and Azure and Active Directory outside Azure Stack, we need to know what versions we can support. So it's anything moderately recent. So you have to be running Active Directory from 2012 or higher, and again, a similar supported version of ADFS on those environments. You can only connect to one Active Directory forest externally, and the forest function level and the domain function level are expected to be at 2012 minimum. So this covers the bulk of Active Directory environments that sit out there at customers today, but you might find you have a customer that's still running at 2008, or maybe they're running at 2012, but they haven't upped the forest functional level yet. So that can be a blocker to actually turning on the ADFS integration until they do some other work inside their infrastructure, which may be hard or maybe not so hard. Again, I'd just like to reiterate the point that we normally would propose that users start with Azure Active Directory as their identity store, because that doesn't paint them into a corner in the same way that ADFS to a single tenant directory on premises might do. Authentication is roughly the same as normal Active Directory authentication works. We use a library. When we connect to Active Directory externally, there's a service account that's configured. And I think that's about it for that slide. So the endpoint. So the endpoint is the service in Azure Stack. You know, I showed you the GUI at the start. There's also an ARM endpoint sitting under the cover. So if you want to programmatically interact with Azure Stack, you're going to be connecting to that endpoint, either the operator, the administrator endpoint, or to a user endpoint. So if you're going to be doing operational stuff like, hey, I want to configure the backup, that'll go to the admin endpoint. If you want to say, I'm a user, I want to deploy 8 VMs, you'll be talking to the user endpoint. So when it says today, in previous versions of Azure Stack before January 2019, this is how the connectivity would work to communicate to Azure Stack. So the user is accessing the portal, we're trying to talk to the endpoint, would go to the URL, here it's saying portal.region.azurestack.external. The portal would do a redirect to Azure Active Directory or ADFS to get a token for that user. So it's the authentication dance. And if successfully authenticated, would redirect them back. And then, depending what you're trying to do when talking to that Azure Stack instance, there will be a number of other services which are extensions to the endpoint. They all run on different ports. So if you imagine the user goes through, talks to the portal on port 443, which is the default, gets authenticated, then gets redirected to go back to talk to one of those extensions. That sounds like one of the traditional terrible things that Microsoft has done to require a whole pile of holes in the firewall. So that's what used to happen or happened up until the end of 2018. This is obviously a problem because if this is an external firewall, you're asking for a whole pile of ports to be opened.
27.
There you go. Look, 27.
Like I knew that was
so. So the solution to that is there's a new capability that's available now in the most recent 2 builds, I think.
Yep. 1811 came up.
To have an extension host. So the extension host is a guy that listens for communications to some of those other extensions that normally would have used a different port and just fires them off, says, hey, somebody's trying to talk to you, I'll just tell you what he's saying. And that way you can have far fewer holes required to open in the firewall. So the process is still the same. The communication to Azure Stack comes along to port 443, goes through the hole in the firewall. The redirection comes, but it redirects you to the extension host, also running on port 443, and then he is responsible for communicating with whatever extension is needed to do the function that you're asking for. So if you need to ask for a VM to be created or a backup to be configured, instead of each of those functions having a different port, you'll just run them all through port 443. So that makes the firewall configuration much more static, and it also means that as we add more extensions, more functions into Azure Stack in the future, it will not require any additional ports to be open. So we go from 27 ports down to a fixed, permanent set of 4 ports. And you'll see in that certificate table that I showed earlier, there were a list of certificates that are required. There's a new certificate required for this extension host. So that came along in November of 2011.
There's also a PowerShell command that we'll show you tomorrow that will check all the certificates that you need and do you have them properly configured. So it'll spit out a report for you. So I'll show you how to do that.
Yeah, and there was a little bit of a hurdle. Whenever we make changes in Azure Stack like this, like a brand new function, there might be an extra hurdle during that patch and update cycle. So you couldn't complete that patch and update cycle and enable this extension host until you had the new certificate, which if you deployed Azure Stack earlier in the year, you wouldn't have had it. So just a few extra steps that'll be in the README that might be required for individual updates. There is detailed fine-grained role-based access control inside of Azure Stack. One of the labs that you will do shows how to select a role for an Azure Active Directory user and assign them permissions to do stuff in Azure Stack. So it works pretty much like you'd expect. There's a set of default roles that can be expanded to be more granular. But there's like an owner, a contributor, and a reader role. And when a user connects to Azure Stack, they will be assigned a role. And when they go to try to do something like create a resource, that role-based access will be checked. So out of the box, there's a few standard role-based access roles set up, but you can extend that and add users in and out of the groups. So you can put a user in a group and give the group role-based access to create resources, etc. It's got everything that you'd expect.
Is everybody familiar? It's RBAC we've started implementing in all of our products, whether it be Exchange or Config Manager. And it's a way that you have to take permissions, and instead of having to understand all the places where permissions can be applied and what permissions are applied, it breaks it down into 3 base components: who, what, and where. Who, the groups that Pat mentioned. So you create the group. What they can do, which is the permissions within whatever product it is that we're working with. Full control, read only. So what are the functions that I can perform in this activity? So we have, for example, we're going to show you in the next module how to create offers, plans, and quotas. So you could create that as a what you can do. So this group can do roles, plans, offers, and quotas. And then the where. Can you do it globally? Can you do it just in this place? Can you do it on just this stack but not this scale? So that's how you break this down and make it fairly simple for you to then delegate permissions for people so that they don't kind of run away with what you're doing. Now, just a pro tip that goes along with this that Pat alluded to, we have some pre-built default roles that are based around our knowledge of how our customers use our product. So we'll have some roles to say, look, I don't know what, here's a read-only administrator, or here's a subscription administrator. And what happens is, as we upgrade our product and add new features or new functions, we automatically change those roles or add new ones to it. I've got a number of secure environments. They do not use the built-in roles. Why? Can I think of a reason?
Too loose or too tight?
It's too loose or too tight? Okay, maybe.
Yeah, well known.
We're going to change the rules by default that are in there by default. And so what happens is you may be an administrator today, but a new feature comes along. I don't want you automatically getting that role. I'm going to explicitly give it to you. So maybe think about that, and that's a skill that you can offer to your secure environments, is to say, never use the default roles. Copy them, but once you copy them, you break that connection to us as Microsoft, changing them. And then any new features that come along, you have to explicitly give them those functions so that someone doesn't all of a sudden get something that they didn't have a previous release before. Make sense? But those become some of the things that we talk about. You take on that role of responsibility from Microsoft, that you will now get that as a RBAC role that you manage for your scale units.
And you might want to get really granular. So the example that Robert gave, you might have a role that's responsible for creating plans and offers. But you might also want to say, I'm okay for you to create them, but it's disruptive if you ever delete them. So I would like to take that power away from you. So you might create a new granular RBAC role that says plan and offer creator, but not deleter. So you're flexible to do that. Again, the caution here is don't go overboard and add a whole pile of complexity from the start. You should probably evolve this gradually as you get used to operating Azure Stack. So what happens in the deployment process? So we mentioned earlier on about there's a hardware lifecycle host. So that's a little bonus server that sits inside the rack, except for Cisco. Cisco uses the UCS components to fulfill this role. It's there permanently, and it's used long-term to manage the hardware inside the Azure Stack. There's also a particular virtual machine that's part of the fabric called the DVM. It's the deployment virtual machine. And it's the guy that kicks off the Azure Stack deployment when you deploy from scratch. So at the beginning of an Azure Stack instance, that DVM is running as a virtual machine on the hardware lifecycle host. So it's the one that kicks off the installation of the operating system on all the server nodes, et cetera. So really, you're going to bootstrap the installation of your Azure Stack from the hardware lifecycle host. So during that initial deployment, the DVM has a bunch of roles. It's like the DHCP server. It's the initial domain controller in that internal environment. So it's got enough guts, enough infrastructure to help you start firing up all the rest of the virtual machines. And then the automated process fires them all up. And the end result of a fully configured Azure Stack means the roles that that DVM took right at the beginning are no longer required, so it can be completely deprovisioned. So it's supposed to be decommissioned at the end. We've seen a couple cases where it hasn't been, but in general, it's there. It's the bootstrapping virtual machine to allow the installation to occur.
Just another quick thing about that is, depending on your vendor, you guys can speak up for us. That's running a Windows operating system that's running Hyper-V that we put the DVM on. So guess what? It's a Windows server. So it should be patched, locked down. You might want to run server core, like all the things you think about that you want. It's just a machine that's out there that is a potential exposure that you're working with. So once the vendor has finished with their DVM component that they're dealing with, you've got to start locking that box down and patching it. And a pro tip for you, it's also where I have a VM that I have that becomes the jump box. Because a lot of these are behind firewalls and I can't get to it from my laptop. So I've got a VM that I run on some of my customers that they run that machine. And so I jump to that virtual machine that allows me then to get into the scale unit itself. So those are creative ways that you might be able to use the HLH other than just the hardware lifecycle host management that you're working with. And to our hardware vendors, you might want to suggest that to your customers to say, hey, here's a hardened VM that's running server core. I'm going to drop this on, and this is what you can use then as a jump box feature for your customers. And we've locked it down and secured it so it's not a security risk for you. Okay?
Real quick, so I get all of like Lenovo and everybody except Cisco puts in, I don't know, one Xbox or whatever it is. How does Cisco handle that?
Good question. I have no idea. I don't know how they kickstart that DVM. Anyone? Do you know? I don't know how they do it.
Yeah, it's magic.
I haven't seen the Cisco hardware myself.
Yeah, so they use the same infrastructure concepts that they do for their Hyper-V model. And so it's part of this thing called the UCS.
UCS manager.
Yeah, UCS manager that spins up a VM that does that for them. So instead of having a separate box, it's done at the physical server level. Yeah.
The other thing that we might not have made clear is that the configuration of that hardware lifecycle host, Microsoft puts some rules around it, but the individual OEMs deploy something different that's specific to them, right? Their own monitoring software, et cetera. So it's a semi-standardized piece, as opposed to the rest of the components are all highly regulated, or there's a lot of rules around them. Okay. So we now have the deployment virtual machine is ready. It's a single virtual machine. The Azure Stack deployment is kicked off from there. So it's the Azure Stack software is all sitting accessible to that virtual machine, and it basically pokes all of the server nodes, installs this Windows Server 2016, is what we have today, onto all those server nodes, creates all the virtual machines that are required for the Azure Stack fabric, joins them all to the Active Directory, tells them where the time server is, does the federation with ADFS. All those steps are kicked off in a long, highly automated sequence of steps. And long is long.
Yeah, 6 to 8 hours minimum, right?
Yeah, so depending on how many server nodes you have, the time will go up. And often after the initial deployment, there's also a patch and update cycle which needs to be run to get the components up to their full state. So in a rough layout of a visit to get Azure Stack up and running, there'll be first a hardware check. Is it all cabled properly? Are there any red lights? Are all the disks working? Okay, hardware looks good. We've got green light test passed. Then there will be the feeding of all the configuration information that was gathered earlier into this DVM to kick off the startup. It'll deploy all the server node operating systems. There'll be some configuration of the switches in between there to make sure that all the switches are configured and ports set up, ACLs plumbed, BGP routing configured. Then the server is deployed, server operating system to all the nodes. Hyper-V will be turned on. They'll all be clustered together. Storage spaces direct setup. Then all the virtual machines required to run the fabric will be piled on top of that set of server nodes. And then the main part of the software installation is done. At the end of that, patch and update, health check, registration, done. So I explained that all in about 35 seconds, but it actually takes about 3 to 5 days, depending how many nodes you So that's the rough process. So even if you never see it at your customers, it's sort of important to understand that this is a lengthy process, but highly automated, and all the answers are driven by the information you gave in that initial information gathering in the JSON file. So after that happens, the customer will get handed their Azure Stack. So they'll have the admin password, they'll know how to log on, they can start doing stuff with it. So one of the first things that often gets done is there's a PowerShell CMDlet called Test Azure Stack. So you can connect up. We'll talk about how you connect up tomorrow, but you can connect up and run this script, and it just does a general health check of, hey, are all the things required to make a working Azure Stack present and running? It's possible that you might have had some failures during the deployment of Azure Stack. So some of the items in here, if they do not pass, might have just been something that happened in the couple of days that were spent doing deployment. Normally this test passes, and then you can be declared to have a healthy initial Azure Stack deployment. Now, here's when you as an end customer will start doing things, and here is a great place for you in this room here as systems integrators or helpful OEMs or anyone that wants to provide some extra value to your customers to jump in. Because there's a long list of things that you could or should do to an Azure Stack to get it into a real operational state. So the first thing to keep in mind is that the PowerShell commands for Azure Stack keep evolving. So they actually should be obtained from GitHub. There's a link here. So normally one of the first activities you do as a manager, as an operator of an Azure Stack instance, is to get the current PowerShell. So wherever you're going to run them from, maybe it's on your own machine, maybe it's somewhere inside the hardware lifecycle host, etc., is to download all of these PowerShell CMDlets. When you go to your lab environment today, this step has already been done for you. So on the host that's running the Azure Stack deployment kit, development kit, this most current PowerShell Azure Stack modules have already been downloaded. But if you're starting from scratch, you'd have to go to Git, download them yourself. So that's almost always the number one step. Another thing you might want to do fairly quickly is to start integrating the solution into the existing monitoring tools in the environment. And so some of these are OEM specific. All the monitoring that needs to be done of Azure Stack must be agentless. So you can't say, I want to install my own custom agent onto the server nodes of the Azure Stack scale unit. The reason we don't allow that is because the next time a patch and update cycle comes around, that whole operating system on the server is going to be wiped out and a whole new one is going to be pushed on. So if you put any agents on there, they'd be gone too. So everything inside that sealed Azure Stack appliance, if you want to manage it, you must manage it without deploying agents onto the server nodes. So a lot of these management tools are deployed already out of the box in the hardware lifecycle host, and some of them, as Robert mentioned before, can call home to the vendor, report disk failures, outages, etc., so that a tightly coupled service arrangement between the OEM and the end customer can be continuously working. Obviously, with normal IT service management pieces, there's a number of things that you might want to happen. So inside your integrated system, you have a bunch of elements, so the parts of Azure Stack that can report on their health. We'll show how that health reporting works a little bit later. But Azure Stack can emit alerts and events that can be consumed by any standard management and monitoring solutions within the customer environment.
There's kind of a cool feature, SCOM, promote our own stuff, has got the built-in capabilities to manage Azure Stack right out of the box. So we've got a management pack that's available for this. I've got a recorded video that maybe tomorrow, if we have some time. So in the current situation, if you have multiple scale units and you wanted to say do patch and update, you would have to connect to each one individually and run the patch and update process. In the video that if we decide to show it, I'll just commit to it now, I'll show you tomorrow. In the SCOM console, you see all the scale units, and you can run right from the SCOM console the patch and update cycle on them specifically. So it's kind of a neat way to manage these as opposed to having to deal with the graphical interface or the API intersets that you're.
How
The Microsoft ones, yes. Correct, and we'll cover that more tomorrow when we do the patch and update. But so, because this just becomes a server like any other server that you've got. It's a thing that you manage. You just can't manage the guts individual VMs inside of it, but it's just another device that you can manage from ours or any third-party tools.
Okay. It looks more like a single server than it does a collection of servers.
Yeah.
Azure Stack might be reporting one of my server nodes isn't working, but that's just a piece of the Azure Stack in general. So you can see some of the events can be queried directly out of Azure Stack with the RESTful API. Not sure why the arrow's going that way, but your monitoring solution can consume events from Azure Stack. And some of the events flow out through the hardware lifecycle host. So the baseboard management controller, SNMP traps from the switches at the top of the rack, they can all flow out through the hardware lifecycle host and again be emitted out the back of Azure Stack to an existing monitoring or ticketing system. Okay, the other thing is right out of the box, you only have the infrastructure, only the IaaS services. So you have storage, networking, the ability to create VMs, etc. You don't have any of the platform as a service capabilities by default. So built into Azure Stack are web-based platform as a service, so websites, functions, API apps, those sorts of things. And there are also the ability to create SQL and MySQL databases, and those can be consumed as platform as a service by the users of Azure Stack. Those are implemented as resource providers, so it's an extra pack of software, and you need to install them separately. They also, in case we forget to talk about it tomorrow, they also have their own updates that may be applied. And you mentioned something else this morning, which eludes me about. IP addresses? No. Something else, some other consideration we already mentioned about when you turn on the PaaS services. Okay, it'll come back to me.
The resources that are taken out in that n minus up to 2.
Correct. Yeah, that was it. So yeah, these resource providers consume resource even without any users actively doing it, anything with them. So.
Yeah, there's support services. So you're going to have to deploy a A2 or a D2 or whatever VM to support the infrastructure pieces. And so that's where we start to get iterations more than just the n minus 1 point. So you have to plan for those from a resource perspective, but they also get patched separately from the default patch and update cycle, which is just the base scale unit.
So there's capacity and operational things that you can help your customers plan on this side.
How are those reflected in the validation sizing spreadsheet?
So the question is, how do those machines reflect in the sizing capacity worksheet that we're doing? Very well, no. They are there, not there by default. So the sizing and capacity worksheet has 5 tabs. There's an informational tab. Tab number 2, which is my challenge to, I think I've given it to all the hardware vendors here, where you you populate the values for the 5 SKUs that the calculator will work for. And so right now we've got 5 fictitious machines in there. So what I've asked all our hardware vendors is, wouldn't it be cool if somebody came up with, I want to go to partner X, click on a script that populates their SKUs into that spreadsheet automatically. Because right now I have to go to their webpage, find the values, cut and paste, and put them in. I'm getting to your answer here in just a sec. Tab number 3 is capacity planning based on the types of IaaS VMs that I'm going to deploy. And so we have a list of all the VMs that are capable, and you got to go, I'm going to have 5 of these and 2 of these and 4 of those, and it then builds the graphs based around the SKUs that you built. The next worksheet is based on workloads. So I'm going to have to think about workloads, but at the end of the day, they still get built around the infrastructure VM. So you have to know what VMs you're going to deploy for an app service. And so you would put, I need 4 VMs at this size to support app services. I need this many VMs to support SQL services. And so it does calculate for them, but you have to do the translation to say, I have to know what the VM size is to support that app service.
No, you need to do some complicated trigonometry to figure out what items to put in there, right? Like if you're deploying app service, you have to define how many worker VMs you want and how many are dedicated and how many are shared and how many websites. So there's a lot of little complicated figuring out of what your business looks like.
So,
and that translates into VMs.
So what we'll do
So
is,
it's not easy.
as an encouragement for everybody to show up on time tomorrow, 5 minutes before the class starts, I'll actually do a demonstration of the capacity planner tool and answer questions. Right. So if you, what? With PAS, yes.
Guys, just to mention, have you downloaded some like IoT Hub and Event Hub today? Because those are actually starting to consume a lot of resources.
Yeah.
Yeah, and so we'll talk about all the, because we're going to show in like all the templated ones that are out there, right? And how do you take those workloads, translate them to an infrastructure workload plan? But I'll do that as a pre-class tomorrow. Okay?
10 minutes early then.
Yeah, 10 minutes early, sure.
So the other thing to be aware of is there are a number of tools already built that can do stuff against Azure Stack. They're all hosted off here in GitHub. So it's worth having a browse of what tools are there. So for example, one of the tasks that requires a bit of activity is to enable syndication between the marketplace in Azure and the marketplace in Azure Stack. So there's a tool to do that, to help you connect up and select items from the marketplace.
Is the second link up to date?
I don't know. Have you tried it and it doesn't work?
Yeah.
Okay, it's possible it's moved, or it's possible there's a spelling mistake in there. I don't know. We'll try that later on. Maybe it is moved to a different place. But if you go to the top URL, you should be able to see it underneath there, right? Because the top URL has a list of all the items underneath there. So this is just sort of like a handy dandy toolbox for things that you might want to do as an operator of Azure Stack.
And kind of our standard gotcha line. While we own GitHub, we do not vet everything on GitHub. There are 2 repositories hosted and monitored and procured by us. So there's an Azure Stack one. So we will only validate the scripts and stuff that come from those specific repositories. So if you grab a script from someplace else, make sure you know what it's going to do for you. Now, with that said, the script that built the environment that you're about to use, one of our colleagues, Matt McScripts, it runs for 6 hours, and it registers your ASDK, it downloads a bunch of items from the marketplace, it builds the IaaS and PaaS services, like it does, but it runs for 6 hours, but it does literally everything you want it to do to bring it from a deployment stage to an operational stage. So that's a great place to maybe pirate.
Yeah. So it's not an
Plagiarize?
official, like it's not an
Yeah,
official
official one.
Microsoft script, but it's
Yeah, it's from a
very
really
robust and
well-known,
does a lot of
trusted
stuff.
source.
Correct. Correct.
Yes.
That's how we deployed the labs that you're going to see in the class today.
Could it work for the 4-node?
Some parts of it. Some
Yeah,
parts of it can work for
Yeah,
sure. Like
it's
the deployments
it's
the deployment to
PowerShell.
the resource providers,
Yeah.
all that part could work fine.
Yeah, for the deployment of the PaaS and the app services, absolutely will work.
Yeah. So we talked about earlier about the registration process. So first, for registration, you need to decide how you're going to do billing. Are you going to do pay as you go, or are you going to do the capacity model where you're paying for the whole size of Azure Stack every month? So the basic steps to register Azure Stack are you get some information about your Azure Stack deployment, including it's got a globally unique ID for each deployment of Azure Stack. So that's the identifier that's going to be passed up with all the billing meters that get sent to Azure. So you get that, and if you're online, you just register your Azure Stack against a specific Azure subscription. If you're offline in a disconnected state, you can export the information, drag it across via SneakerNet to another PC, connect up and perform the Azure Stack registration, and then you get an activation key back, and you take that key back to your Azure Stack and say, hey, you registered with this key. So there is a completely disconnected way of doing the registration. Obviously, that disconnected one means you're doing a capacity model bill. So it's just reporting up to Azure, hey, this is a 4-node Azure Stack with this configuration. And then Azure knows how much to bill you each month for that size of Azure Stack. It's possible to change the registration. We'll talk about that in the things that are available to be done or undone. So you can change from a consumption to a capacity model You can also make scale changes. So if you had a disconnected Azure Stack that started life as a 4 node and you added four more server nodes to make it an 8 node, you need to re-register it because now you have more capacity available in your Azure Stack and your monthly bill should be proportionally higher. Okay, so we mentioned that you can renew or change your registration. Normally, if you have a capacity-based model, you would renew it annually. If you want to change the billing model, you can. There's a couple caveats, which we'll talk to in a second. And obviously, if you change the scale of your Azure Stack, you need to re-register. Okay, so just one last topic, and then we'll talk about the gotchas, the decisions that you want to make absolutely correct. So this is just a general philosophical discussion you need to have with someone that's purchasing Azure Stack. So in Azure, public cloud Azure, the top cloud, if you're an Azure customer and you want to consume resources, you want to set up some VMs or consume PaaS services, you get a subscription and you go and pull those. All the rest of the work is done by Microsoft. So Microsoft is operating everything. We buy the hardware, we run the data center, we do the monitoring. If there's hardware failures, we accommodate those.
Patching.
We do, patching and updating. So we take all that work away from you if you are a public cloud subscriber. If you are an Azure Stack customer, you are taking on a lot of those workloads that Microsoft does for you in the public cloud. So you're going to buy the hardware, you're going to provide the HVAC, you're going to monitor it, and if anything goes wrong, it's your responsibility to service it, replace hard disks, whatever. That responsibility might be shared. So if I'm a service provider, I might buy an Azure Stack and I might operate it, and my end customers see it as if it's like a public cloud. So I'm operating it as the cloud service provider, but somebody's doing it that's not Microsoft. So you can imagine there's a number of ways to factor this, who does all those operational tasks. But that's the key thing to understand. And that's why when you buy a VM running for 1 day in Azure Stack, it's a lot cheaper than buying that same VM that's running for 1 day in Azure. Because all the extra cost is borne by that yellow circle guy over there, because he's the one doing the operations. He's the one that's paid for the hardware.
And there's multiple iterations of this. There's 2 specific roles. And this is where some of our vendor partners, as you know, even the providers, this is a service that you can provide. And we have these documented. What is the skill of an architect? And that's the questioning of your customer to say, what kind of workloads are you going to put on here? And identifying that path to, what kind of VM do I need for that? Like, oh, you're running SQL. Do I need SSDs? Like, are you looking for volumes of storage? And so this is big scale stuff. And this is going to talk about even the next module we're going to get into. Designing plans and offers and the quotas that go along with that. But then you got to turn it over to the daily operator. And so this could even be offered as a service by a service division of a partner to offer that to their customers, because it needs to be done. And maybe a customer says, I don't want to own that skill, I want to borrow that skill, but I want to operate the actual scale unit itself. And it's at this point that you have to then monitor the usage of the scale unit to see if the quotas are taking control and not giving away too much hardware, and when do I need to order the stuff. But they are 2 different skill sets, but they need to be managed and worked for because you're taking on the role of Microsoft.
And we've seen a lot of the early customers sort of take on that operational role, but not be the end consumers. So we've got government agencies that are like a service provider to the rest of the government. We've got cloud service providers that are offering, hey, there's no public cloud Azure in New Zealand, but we can give it to you and guarantee it's in our data center. So there's a lot of cases where that operate is done by some sort of service provider, and then the end users are just consuming it in much the same way as they would consume public cloud.
And we've got a number of service partners that are providing that specifically for their customers. Say, you buy them, we'll come in and manage them for you. Like when we were in India, we were like, you know, that's what they're going to do is we'll design it, we'll build it, we'll deploy it, manage it, but it's yours in our data center. Like all the different operations, they're just great business functions.
So we've alluded to this already. Obviously, under the covers, there's some Windows servers running, there's clustering, there's Hyper-V, there's a whole bunch of networking configured. If you were to administer this on just a regular hypervisor platform, you would use all the familiar tools to manage that today, and you'd service it. In Azure Stack, that's different. You should not have to have the deep management of all the tools to use to manage the individual components. That's abstracted away from you. So again, that's part of the magic of Azure Stack, is that you shouldn't have to know all that deep experience of the underlying platform. That's taken away from you. So there traditionally were a bunch of siloed skills required to make a virtualized hypervisor platform work and run services. So these are all kind of stuck together in Azure Stack, and the way that you manage it is very simplified. You either manage it through the portal experience, or you manage it by connecting to the resource manager endpoint using PowerShell or RESTful APIs. And Azure Stack will diagnose its own problems and emit events, actionable events that you as an administrator can take care of. So the philosophical statements about operating Azure Stack are, if you are a cloud admin, if you're an operator of Azure Stack, you should be able to manage the whole thing. It should tell you enough about its own problems or its own state to let you manage it without having to call in the networking guy and the virtualization guy, et cetera, et cetera. There's really only a single access point, which is viewable either in the GUI portal or through Azure Resource Management, Azure Resource Manager. So that's the place that you would talk to Azure Stack. You shouldn't have to do all this tweaking like you might do. You might say, oh, I need to update the firmware on my storage bus controller. None of that you have to worry about in Azure Stack. That should all be combined into the monthly patch and update cycle. And the bottom line is you're managing the service of Azure Stack. You're not managing a whole bunch of disparate infrastructure systems. So that's a philosophical statement.
Yeah, and I hope I'm not going to denigrate anybody's skills that they've had in the past, but this is that paradigm shift we're looking at. And the term I use is you're no longer keeping the blinky lights blinking, right? That's not your job. Your job is to monitor the console, and it will tell you, in many cases, what's wrong. So in the past, as the storage person, I would know how to carve a LUN up and how many IOPS I could get from the partition size and how many blocks. Like, you don't have to worry about that because it'll tell you, hey, there's a hard drive that's failing. So you don't have to worry about the blinky lights. In the old IP world, you were the networking guy, so you knew everything about TCP/IP, and you knew how to sliding window sizes, and you knew how many public IP addresses you had. You don't have to worry about that anymore. You get given a bunch of public IP addresses, and you consume them, and they'll be told whether you have enough or you don't have enough. It will tell you you're running out of public IP addresses. You don't have to know everything that there is about public IP addresses. Make sense?
But the value of those skills, as we were talking about,
yeah, they don't go away.
Yeah, if you knew how to figure out how many IOPS you're going to get out of your storage array, that's still a valuable skill, because when a workload comes onto Azure Stack, you're the person that can ask the sensible questions. Oh, how many IOPS do you need? Are there bursts? Are there peak times of the day? Can I shut down some part of your scale of the system over time? So there's still a lot of value for those same people with the same skills to have. It's just different. They aren't fiddling with registry entries and that sort of stuff.
Calculate that on Azure Stack. So a user comes to me or a customer comes to me and they're like, I need 5,000 IOPS, my block size is this, my read-write ratio is 30/70. How do you take that information based off of your Azure Stack and say I can satisfy that?
So there's a few levels to that. So one is selecting the right VM size, right? Because as we mentioned earlier, the VMs are capped in terms of IO limits and stuff like that. So if you pick the wrong VM size right out of the box, you're done. So you've got to right size the VM. And then you have to have the whole architect overview of what's running on your stack. Because if you have a heavy disk IO thing running in this one VM and a whole bunch of lightweight ones in other it's
And I'm going to kick that over to our hardware people, because because at the end of the day, Azure Stack makes the services function. But at the core level, like when you're getting down to the IOPS levels, there's some of the things that I can control through Azure Stack, but most of it's going to be hardware dependent. So if you buy the wrong hardware, I don't care how well I tune it in Azure Stack, I'm not going to get those IOPS. So you have to sit with your hardware vendor and say, what disk configuration of the 4 SKUs you're going to give me is going to meet this requirement that I'm dealing with.
One other coloration of this conversation is it's really hard to talk about disk IOPS in Azure Stack because underpinning all the storage is storage spaces direct. So when you ask for disk, you just say, give me some disk. But storage spaces direct under the covers says, hey, I've got some high-speed flash disks and I've got some slower speed spinning disks. I'm going to put whatever data is accessed most frequently or most recently onto the fast disks. And other stuff will just degrade out and go onto the spinning disks. So even if you're a VM and you make 2 requests for 5 gig of data, one time it might be really fast because that's coming off the fast disk, and another time it might be way slower because it's coming off the hybrid disks. So it's that storage spaces direct kind of obscures disk performance a bit.
Yeah.
You're speaking of something where there's a caching tier and then
Yep.
there's a secondary tier.
Yeah.
That's not true in the case of a all flash.
True.
Yeah.
Yep. If you have all flash, you're guaranteed.
Right? Because now you have managed disks, you have premium,
Yeah.
so this is just a longer conversation that we'd have to get into contact with your OEM and discuss that.
And that's why I said you have to build scale units for workloads because you just can't have one scale unit that's got a bunch of SSDs and a bunch of spinning disks and a bunch of this, and I'll pick this. You're not doing that because it's just hyper converged. And if you want all flash, you got to build a scale unit that's all flash. And if you want tons of storage that's all spinning disks, you got a scale unit that's all spinning disks. Then Azure, as it is in Azure, becomes the restriction. So you could have only one VM running on your machine, and if you picked an A2 or a D2, that becomes the limit. I don't care how much capacity I got in there, that becomes the limit of what you're going to get, based on the limits that's published through Azure.
Okay, but there's no like if I build a stack though, right? And I don't mean to take to that point, right? Let's take a web app.
Can I interrupt though? Just from a time perspective, yeah. If we can either take it offline or maybe in another module. So we have some we're going to, I think, answer some of it. Okay?
Okay, so the last little section here is we alluded to a bunch of decisions that you might make that could be very bad or just a little bit bad. So this just recaps them into a couple of slides. So there are some decisions that you might regret making, and we've seen real world example cases of this. So there's a couple of categories. One is these are bad decisions that will make you redeploy your Azure Stack. And that's the whole week-long process we just talked about. The OEM comes in, they suck up your answers, you redeploy Azure Stack. Any workloads you had on it, you've got to be responsible for taking them off and putting them back on. You've got to re-download the marketplace, all those steps. So that's the disastrous case. There are some other decisions that you might make that would be bad, but you can work your way out of them. So we'll divide them up into those 2 categories. So here's the things that you might change your mind on that would cause you to redeploy your Azure Stack. So you chose the wrong authentication method. You chose the wrong name for your tenant. So Robert's point about if you have a long-term vision for Azure Stack with a name associated with it, you might not want to use that name right at the start because later on you might be deploying multi-region Azure Stack. If you want to change even the region name, that means you have to redeploy. If you want to change the internal domain name used for Active Directory, you need to redeploy. That sounds like it might not be a big issue, but I think we've had at least one case where someone named the internal Active Directory the same thing as their existing Active Directory. And then when they try to federate, it doesn't work. If you pick the wrong initial IP address range, so we can add new address space to that range, but we cannot change the initially deployed address space for the public IP addresses. If you use self-signed certificates for your deployment, and now you want to use certificates issued by a public or an internal CA, that's a redeployment. If you used public certificates and you want to switch to an internal, like an enterprise CA certificate, then you have to redeploy. Obviously, we talked about disconnected mode. You don't want to deploy using external public certificates because you don't have connectivity to the certificate revocation list. If you pick the wrong hardware, like, oh, I've got the wrong CPU family, wrong server spec, any of those things, you cannot change that without redeploying Azure Stack. Or if you pick too many server nodes, you can't claw server nodes out of a running Azure Stack. You can add to an existing Azure Stack up to 16 nodes, but you can't remove. There are other things that you might decide that would be painful to change. So we're going to talk about plans and offers in a minute. If you make some plans and offers and your users start accepting them and deploying stuff, you can't really remove that offer, right? It would be like your cell phone provider saying, hey, I'm going to give you 5 gig of free data, and then they retract that offer from the marketplace. They can't take away your 5 gig of data because you're already using it. If you want to point to a new Active Directory on-premises environment, you can do that. But obviously, anything that you granted permissions to those users to before from the old AD, they're all going to go away. So you're going to have to redo all those permissions. If you bought insufficient capacity, you'll need to add more server nodes. And that's possible. The only reason it's painful is because you got to order them and get them installed and yeah. So it's not a quick change.
Or you can do what one of my customers is doing. You can add compute and you can add memory, but you have to down the entire scale unit and have it offline during that process. But you can't add storage.
If you wanted to change from static routing to BGP routing, you're obviously going to have to take an outage to do that. It's perfectly possible, but you can do that. If you have things outside of Azure Stack that you're sending traffic through and there's not enough network capacity there, that could be a problem. So those could be firewalls, it could be a transparent proxy, or in the future, an actual forward proxy. So if those things are starving you of bandwidth, then you have to fix those things. We mentioned that you can re-register or change your registration inside Azure. That's not painful to change, except the painful part would be if you change and register from one subscription to another. At the end of the year, if you're looking at bills, you're going to have to look at bills from 2 different places. You can also change from the capacity billing model to a consumption billing model, but you need to pay for the rest of the month at capacity, and then the change will affect. We'll talk about the SQL and MySQL resource providers. So both of those point to a place, a database server where you would host databases for users to consume. You can change the place that you point to, but that's obviously going to create some downtime for the consumers of that database. So you might have sized your SQL server improperly at the start and pointed to it, and now you want to point to an even bigger SQL server. Possible but painful. That's it.